Now we will start with the module 2. So module 2 is basically about how we do the knowledge modeling. So in this particular module, we are going to talk about the three things. That is, what is the methodology that we use for knowledge modeling? What is the conceptual diagram that we have followed for creating the metadata? And how we have developed the ontology using the Protege software. It is open source software that we have used for creating the ontology. That is the metadata schema. Or we can call it. So here is the methodology that we have used for creating the ontology. So the very first step here in the methodology is the knowledge acquisition. We used to get the knowledge from the different resources like the Wikidata, the Olympic site, the Kaggle dataset that the Olympics dataset that we already have gathered from the Kaggle. So we used to look at that data, how the relations can be made, or what are the resources, different resources from where we can get the Olympics data, what are the different kind of information that are included in the Olympics data. And once we gather the knowledge, we used to move towards the second stage. So in the second stage, we used to determine the scope, means what is the scope of this data. If we want to determine the scope, what will be the use cases? Like for example, as I have shown you the use cases regarding the athletes, if I want to find out the top 10 athletes, whether they are the according to the height or according to the weight or according to the medal count, what is the statistics of the country, means the country with the highest medal count, the country with the highest players to participate in the Olympics. So these are nothing but the scope determination. So we used to determine the scope using the competency questions. So competency questions are nothing but the questions that we used to keep in our mind, or we used to make a list of it, and then we used to create the we used to determine the scope. That is how we should link the entities, or how we should link the different data, or the what should I say, the classes to another classes, so that we can infer that knowledge. So now once we have determined the scope, that is what will be the scope for the data, we will move towards the third stage, where we will do the concept extraction. So concept extractions are nothing but the concepts that are there. So for example, if we talk about the Olympics data, so the concepts there will be the athlete. The athlete is having the weight, the height, the nationality, the continent. Then it will have the gender. It will have the various athletes information for the country. If we want to see the country, who was the host country, for what kind, for which year of the Olympics. If we want to talk about the sports, then what are the different kind of sports that are there in the particular data, and whether the particular sport is a single event sport, or if it is not, if it is a multi-event sport, then what are the different multiple events of a particular sport. So these are nothing but the concepts that we used to extract from the knowledge that we have gathered in the first two stages. Then after that, we used to move towards the fourth stage in the methodology, that is the ontology architecture. So here we used to determine or depict that how we require the architecture of the ontology, where we need to build the ontology using module by module, or we need to create an ontology in a single way, or it should be distributed. So it totally depends on this stage, means this stage particularly determines what will be the architecture of the ontology. Now if we talk about one of the architecture that we have used, is nothing but the module. So we are having the different modules, like athlete is one module, country is one module, event, a sport is one module. So what we have done, these are the different modules that we have designed, and after designing these modules, we used to link those modules to get the connectivity. So this particular four stage determines what architecture we need to follow for creating the ontology. Then the stage 5, 6, 7, and 8, these are kind of the iterative stages, where we used to create the conceptual diagram. After creating the conceptual diagram, we will encode it into the OWL language. OWL is nothing but the web ontology language, in using which we used to create our metadata for our applications, for our data. Then formalization is nothing but whether we require any rules. Now why do we require the formalization? For example, if one class is attached to another class via a particular relationship, So this relationship is explicitly mentioned in our ontology. But there are some relationship, there is some data which is not directly mentioned. So we need to write some rules for that. So it is not always necessary that each and every ontology will require the formalization. This particular step is a totally optional one according to the ontology that the developers wants to develop according to their use case and according to their application scenario. So here we used to write some rules, and then we used to do the evaluation in the eighth stage of the methodology. So evaluation will be basically based upon the completeness of the ontology, whether the ontology is consistent, or are there any pitfalls, or there are any errors, or there are any entities which are not linked with one another, or those are left behind, or whether there is any duplication or redundancy. So the eighth stage is where we used to do the evaluation. So once we have done with this all the four stages, and we are okay with our particular ontology designing, that now this is the final design, then we used to deploy it on the internet. So there are various ways of deploying the ontology on the internet. So deploying is nothing but publishing the particular ontology on the net on the internet, so that different users can use it. So this is regarding the methodology that we have followed for creating the Olympics ontology or the hologram. So this is the conceptual diagram. The blue one are the main classes, and the main classes in the ontology, and the white rectangles are nothing but the attributes. So as we have said that as there is an athlete, athlete will have the name, it will have the age, it will have the height, the weight. So these are nothing but the data properties of the athlete. Then the country, as you can see that this particular athlete is connected to the country. So country, it is highlighted in blue. So it means it is a class. It is not a simple attribute. Okay. So here the athlete will get connected to the country via a object property. Okay, because these are the two classes, and two classes gets connected using the object property. Here the name, age, height, and weight, these are the direct values related to the athlete. So here it will come the data properties that we will use to link the values to the athlete via the data property. And then we are having NOC is nothing but the National Olympic Committee, whether the particular country is a part of it or not, to which continent the particular athlete belongs to. In the same way, the game will be there. In which city the game has held, what is the season, whether it is the summer season or the winter season Olympics game, and what is the year, the name of the games, and the medal is also the class which will have directly the object property, that is nothing but the value, whether it is a gold medal, silver, or bronze. So this is the conceptual diagram that we have created. This is the same documentation that we have shown you earlier of this particular conceptual diagram. So now we will move towards how do we create this kind of an ontology. So for creating the ontology, we are using the Protege software. This is the free open source ontology editor and the framework for building the intelligent systems. So this is the site of the Protege, the official website from where you can download the Protege. And once you download it, I'll just open it. This is how the Protege looks like. This is the base URI. You can see here. Basically, this is the by default URI. Once you publish it on the internet, or if you have your own domain URIs, you can also use it for creating the ontologies. So here you can see this is the generalization of URI, that is the IRIs. And here the another tab are the entities. What will be the entities in our particular ontology means the classes, athlete, country, and the game, sport, event. These are the classes. Then these classes will have the object properties and the data properties. Annotation properties means to give the information regarding any particular class, what the class is all about, and what are the comments. Then the data types means what kind of information that they are storing. So for example, if we just see that the athlete is having the name, so we can consider that particular name as a string. So it will have access this string in this way. So it will map to this particular object data property. So, and individuals are nothing but the instances. But basically, ontology is nothing but the name itself says that it is a schema, it is a metadata. So, the ontologies never used to have the instances. Instances are nothing but the data that we have, and we used to map that data using this ontology. So, now if you want to create the ontology, the first thing that we will define is the classes. So, if we want to define any classes, we need to select this owl thing. This is the super class, and all the other classes will be the subclass of this owl thing.
Pooja,
Yes, ma'am.
we can see your browser only.
Oh, okay, ma'am. Just give me a second. Is the protege?
Yes. Yes, now.
Okay. Okay, ma'am. So, do I need to explain it again?
You could brief it.
Okay. So actually, this is the protege UI, how it looks like once you download the protege. Okay, this is the base URI that you will get by default, semanticweb.org. And then this active ontology is nothing but here you will specify the things regarding to your ontology. This is the ontology matrix. It will tell that how many exomes are there, how many subclasses are there, how many object properties are there, the different types of object properties, the data properties, and everything. And then this is the basic ontology IRI. Here you can change this if you have your own specific domain IRI, means if you want to use it, or otherwise once you publish it, it will get changed to the published one. And here in the annotations, you can write regarding the ontology description. That is what this ontology is all about, who has created this ontology, what is the version of this ontology, and the abstract of this ontology. So then there is the entity tab. In the entity tab, once you open the entity tab, you can see some different sub tabs of it, sub menus of it. So these are the classes. So our thing is a very super class. This is it tells us regarding the class hierarchy. So as I have shown that particular conceptual map, the blue ones are nothing but the classes that are there in the ontology, and the white ones, the white rectangles are nothing but the attributes that are there in the ontology. So whatever the classes that we have, we used to add those classes here. So for example, if you want to add the class, you can just add it here in this way, add subclass. For example, I add it as athlete. Okay, so you can see here that this is the base IRI that is getting created. After this IRI, there will be the hash, and then this is the name of the class. Okay, and as you say okay, then here it will get added. So if you want the particular another class, you can actually add the sibling class or the subclass of it. So as we do not have any subclass, we have the sibling classes. So here it will be, for example, the game is the class. Okay, here in this way. Now in this way you can add the other classes. Now here you have to make one thing sure, that athlete and game both are the different classes. They used to store different information. So what we used to do, we used to use this disjoint with, means it will tell us that these particular classes are not similar. Athlete will get disjoint with the game in this way, and in the same way as you will done it for the athlete, it will automatically be done for the game also. So game is different from the athlete class. So in this way, we can write all the classes that we have in our ontology conceptual diagram. Now comes the object properties. So object properties are nothing but the relationship that defines that we are using for linking the two classes. So here, for example, athlete is one class and game is another class. So how the athlete is related to the game class? Athlete has participated in game. So has participated in will be our object property name. So for example, if we want to create the object property, you will click on the add sub property, and for example, you can actually add the list or the hierarchy of the properties, or you can just simply add it here, add a single sub property. So if I just write it here, has participated in this way. Okay, so you can see that we are getting the base IRI, that is the base IRI of this ontology, and then hash, and then has participated in, and then okay. So now this is the has participated in this particular object property tells us the relationship between the athlete and the game class. Now how we should define? We have defined the name of the relationship between the both classes, but now how we will specify that this particular object property is defined only for those two classes. So here there are two things that you need to do. Here you can see on the right hand side there are three, the screen is divided into three parts. There is the annotation, the characteristics, and the description of that particular object property. So here in the description part you can see two things, domain and range, domains and ranges. So domain is nothing but the main class which is getting connected to another class. So here athlete is the one who is participated in the game, so the object property domain will be the athlete. So if you want to add that thing here, so the domain will be the athlete and the range will be the game, in this way. So it tells us that the athlete has participated in the game. Okay, then the game will have the another attributes like what is the name of the game, in which city that game has been played, in which year, means whether it is summer game or winter game, what is the year, what is the city. So these are nothing but the attributes. So in this way we have defined a single object property. So object properties for between two classes. Now we have the data properties. Now if you remember, we have the conceptual diagram where we have talked about the athletes are having the several information related to it, like what is the height, what is the weight, what is the name, what is the age, what is gender. Okay, so this particular properties, these particular attributes are nothing but the name or the value or the information related to that particular athlete. Okay, so here to add that particular data property, here we will again, you can actually right click it and add sub properties if you want to add more than one, or you can also go one by one in this way. So here if I want to add has name, okay, so has name is the data property. So who is having the name? The athlete is having the name. And what kind of data it will store? It will be a string. So again, in the same way, the domain will be the athlete in this way. And here the range for the object for the data properties will not be the class. It will be the type of value or the data type. So the name will be a string. So we can take it as XSD string in this way. So you can see here that the domain is athlete and it is having the data property has name. In the same way, if I want to add more, I can add more data properties like has age in this way. Then we can also add has height in this way. Now you can see that I have not changed my cursor, so has height became the subclass of has age. So this is not correct. You can actually move it in this way to the top. Now has age, who is having the age? Athlete is having the age, so we will take the domain as the athlete, and age is nothing but it is an integer value. So built-in data type that we will take is XSD int or XSD integer, whatever you want to take according to your requirements. So in this way, now you can see that has age is also been defined. Now has height. Height is also the data property. So height, we will call it, if we want to put it in the form of centimeters, it will be the floating value, or we can actually take the floating value, the double decimal float, whatever you think. So if I just take it double, so you can see that has athlete now has the range as double, means its value will be the double. Now the annotations are nothing but here we will provide some information regarding the object properties or the data properties or the classes. So you can see RDFS comment. These are the different particular annotations that are available. So comment is nothing but if I want to tell that what this particular data property is all about. So it tells the height of the athlete. So in this way, I'll also require to select the language, that is English, and then okay. Now you can see that this tells that what this data property is all about. It tells the height of the athlete. In the same way, you can do the annotation for the object property. In the comment, I will add it as in this way. Again, the language, and then okay. So in this way, sorry, if you want to edit it, there is a small icon here. You can also edit whatever the comments that you have written in this way. So now we have two classes, game and athlete, with one object property has participated in and the three data properties which are related to the athlete. Now, if we want to see this particular ontology, how it looks like. So here, here you can actually use the OWL visualization, which is the by default tab you will get for visualizing your ontology. In this way, you can see here, game is the OWL thing, and then athlete is the OWL thing, or you can also go for the ontograph. So here I have the OWL thing. I will expand it. It is having two, the game as a class and the athlete as a class. And you can see the orange one, it is nothing but the data property. You can see when I have hovered on it, it tells that athlete has participated at the domain and range, the game. So in this way, once you build the whole ontology, you can also see its visualization. So this was the short demo regarding the ontology, that how we used to create the ontology. So if anybody is having any question, please ask it.
Pooja, could you display the whole ontology that you have developed for Olympics?
Yes, ma'am. So yeah, this is the whole ontology that we have developed for the Olympics. So
Cannot see.
yes, just my screen share is paused. Is just give me a second. I'll just have to share my screen again. Is my screen visible?
Yes.
Okay. So this is the ontology that we have created for the Olympics. We are having all these classes: athlete, city, continent, country, event, and these are the number of object properties. These are the data properties that we have, and it is how it looks like here if we want to do the visualization.
My question is, do you find some scope of improvement, some extension scope for this ontology?
uh, yeah, actually, there are, so right, basically right now we have not provided any exoins or the rules for the ontology to infer more knowledge or the reasoning purpose. So what we can do is, once we define the ontology, we need to add the rules that uh, how it can what should I say, whatever the knowledge that is not present there, how we can extract that, infer that knowledge using the rules. What are the kind of exoins that we can mention, the reasoning or the knowledge which is not explicitly mentioned, but it is there. So there are a lot of improvement. There is a scope for improvement in this particular ontology.
Because it is an ongoing project.
Yes.
Okay. Will you like to go through the documentation once?
Uh, yeah.
Means you evaluated the ontology and then you published it on the web.
Yeah, regarding the publication, the evaluation purpose, we have used the ontology pitfall scanner for evaluating this particular ontology. You can see that this is the athlete class. This documentation that you can see here for this ontology, it has been created using the ontology tool, which we have used for the publication purpose. So basically, these are all the classes. It tells us what is the IRI for this particular class, is in the domain of what, and is in the range of which particular object property. So here DP is nothing but a data property, OP is nothing but the object property in this way. So you will get each and every information here regarding this. So for example, has continent is the object property, it tells us that the country is the domain of it and the continent is the range of it. So you will get the information in the whole documentation format. Now, as we have told you, the evaluation is basically done with the help of the the OOPS, that is the ontology pitfall scanner. So this particular tool is used for evaluating the ontology. It tells us that whether there are any pitfalls, that is, if there are any classes that are not been linked with one another, or if there are any naming conventions that are there in the ontology that are present there. There are also other tools like, for example, ontometric tool, RDF validators, etc. And you can also use the reasoners. So basically, these reasoners are nothing but also one kind of a tool which are used for the evaluation of the ontologies. So there are so many reasoners that are available, like Hermit, Pellet. Hermit and Pellet are the particular reasoners that by default came in the Protege. If you want to add some more, then you will have to add the plugins for the same. So these particular reasoners are basically used to infer the knowledge, means whatever, like you can see that the athlete and the game, this particular two classes were directly interconnected. But if the athlete is again connected to some another class, that is the sport, so that particular sport is nothing but having the relationship with the game, but we have not connected the sport class with the game class. You can see here the athlete, for example, is connected with the game, for example, and then the athlete is connected to the sport, but the game and the sport are not connected with one another. So here we are not mentioning explicitly this particular relationship, but the reasoners are the one which used to infer that knowledge, which used to generate that implicit knowledge and used to make it explicit. So this is why the reasoners are basically used for. And you can publish the ontology using the different tools. Like we have used the ontology particular tool for publishing our metadata on the web. For the documentation purpose, it used to use the Vidoco. You can also publish your metadata with the permanent with the permanent ID, that is using the W3 ID, permanent IDs and etc. So this is regarding the evaluation and the publication of the ontology. So if there are any questions regarding any module, one or two, we can have it. Or
Okay, you are done with module 2 now.
yes.
So I wish to ask a question. May I?
Please go ahead.
Yes. Reasoners means I just want to know whether this is verification. You have verified this whole ontology. Have you verified the whole ontology by using this any tool?
Yeah, means look, reasoner and verification, I think both are the different things. Reasoner is basically used for inferring the implicit knowledge and make it explicit. As I have told you, if two classes are not related, are not connected, but there is some relationship via some third class, so what the reasoner will do, it will extract that knowledge. So reasoners are basically for inferring more knowledge regarding the connectivity of the classes. And if you say the evaluation thing, the evaluation is regarding the consistency, whether whatever the ontology that we have used, whether it is consistent, whether it is complete or not. If there are any pitfalls in the ontology, like for example, it happens that there are some naming conventions that are present there. There are some critical issues that are there in the ontology, like many classes are defined but they are not linked, or the information regarding some classes is not present. So in this way, evaluation and the reasoning is one part of evaluation, means which we can use for the evaluation purpose.
Pooja, could you spend a few minutes demonstrating the OOPS pitfall scanner?
Yes. So for example,
we have done the verification using OOPS.
Yes. So for example, just give me a second, I'll just open the
and also, I hope you have run some Sparkle queries. You have validated your ontology using some competency questions, right?
Uh, for ontology, we currently we do not have any competency questions, because basically ontology knowledge modeling is based upon the two things, that is the T box questions and the A box questions. So T box
Yes.
questions are nothing but the questions that are there regarding the classes, that is regarding the schema. And if you talk about the A box questions, that are nothing but the assertion box questions. So these particular questions are basically based on the data that we have. So as you can see, there were no subclasses. All the classes were the individual classes, and they were having the attributes. So there were no any T box question. That is nothing but the terminology question. So for example, if you just take any different ontologies, so if you want to find out that how many different type of this particular class are, so what the question will do, it will extract all the subclasses of that particular class. So these are the T box questions. So currently we do not have any of the T box questions. But yeah, we have the A box questions that we have done using the Sparkle queries that will be discussed in the fourth module. So regarding this, just give me a second. I'll just run this oops pitfall scanner.
Excuse me, ma'am. Can I ask one question?
Please go ahead. Sarika.
Ma'am, which tool you have used for conceptual design of an ontology?
There are actually various tools. You can actually use the draw.io or the Lucida Art. There are various different tools that you can use for the design purpose. So now if we want to verify what I'll do, I'll just Google it so that everyone will be able to say. So here, for example, I just put ontology pitfall scanner. You can see here oops.linkdata.es. So this is the one which we have used for the verification purpose. I hope my screen is visible.
Yes.
Okay, so the thing is, this is the very first ontology that we have created. Okay, so why I have taken our first version, because it were having so many issues, so that I can tell you how this particular oops used to work. So if I just scan this, you can see that I have put the whole ontology. One more thing that I would like to tell you, that if you want to save this, you can actually save it as a turtle file, as a RDF file, or as a OWL file. Okay, then you can grab the whole content from that, and you can directly put it in this particular text rich text box that is present here on the oops platform. And you can see I have pasted my whole ontology here, and once I click on the scanner by RDF, then these are the evaluation results.
Pooja, you have used two new terms, so please speak something about that. You said the different serializations, turtle, RDF.
Yeah, actually, regarding the same, we are going to talk in the third module. But if I want to give the overview of it, so
Yes.
it's nothing but the resource description format. It means the way we used to store the information for the linked data. So RDF is basically having the triples, as we have seen, that the subject, object, and the predicate. So if we want to relate it with the example, so athlete has participated in game. So here the subject is the athlete, has participated in is the predicate, and the object is nothing but the game. So RDF data is in the form of a triple. So these are the serializations that we used to use for storing the linked data. So you can actually use it, the different ways of serialization. So this is the ontology that we have developed as a very first version. And if you just evaluate it, you can see that these are the evaluation results. So the oops tells us that if it is red, there are the critical issues that are there in the ontology, that is, it is not consistent, the reasoning is not mentioned, the applicability is also not present, and the orange ones are the important ones, means even though they are not critical, but there are some kind of a pitfall. So for example, if you just see this orange one, so it is saying that the disjoints are missing. So disjoints, as I have told you, I have made the athlete disjoint as the game, because both other classes are different, they are storing different kind of information, so they will be the separated. once. So it is saying that the disjoints are not mentioned. So this is the important issue. There is one more important issue is the license is not mentioned. As we have told you that linked data, semantic web, link open data, each and everything will be available openly, right? So we need to provide the license. So the Creative Commons license, you can see, you can search it on the web. It is most probably used for the open license purpose. Means we are making our particular data as open license. Anybody can use it, anybody can republish it, anybody can modify it in this way. And then the minor ones are, it is not really a problem, but you can see by correcting it, it will make your ontology nicer. So for example, as I have to, it is telling us that there are these many of the classes, and this particular classes are, sorry, if you can see has word is there. So these are the object properties and the data properties. It is saying that there are the annotations are not mentioned. As I have told you earlier, annotations used to tell us regarding that particular property or the class, that what the particular object property or data property or the class is all about. And there are also some 12 minor issues, like it is saying that inverse relationships are not explicitly declared. So we need to also specify what are the inverse relationship. Now inverse relations, the symmetric relations, these are the different kind of relations. As we will evolve further, you'll be able to understand it. And it is also saying, as I have told you, that naming conventions is also one of the issue while designing the ontology. So it tells us that there are some cases, that is the name conventions. That is, if there are multiple cases, you can use the delimiters like the hyphen or the particular, what should I say, the underscore. So there are basically 41 to 42 pitfall issues that are there. So you can see the pitfall catalog here in the documentation of this particular OOPS evaluation. So if anybody wants to ask anything else.
If the audience have any questions, you could please unmute yourself.
Ma'am, can you please give some overview on conceptual design? Is it, if it is possible?
Overview means in what?
Actually, I need to design a conceptual design for my ontology, but I'm not able to do that. How we can connect the classes with the different classes or relations? What we can, how we can do that?
How we can? The first thing is you will have to find out which are the classes. Means the first thing is, just tell me one thing. You must be clear that what are the classes in your ontology. You must be having that picture clear, right?
Yes, ma'am. Yes, ma'am. Yes.
Can you just give some example so that I can?
Ma'am, in my ontology, I have 120 classes, 128 classes. Like I have started with entity. Suppose the basic thing that I have started with entity, then it is divided into two parts, abstract and concrete entity. Again, that is the division of different classes.
So you want to ask that how you can make the conceptual diagram of this particular thing.
Yes, yes. It is actually, it is an upper ontology. That the name I have given is super ontology, and it is started with basic entity, and it will come back to the instances like a human being and all.
Okay.
Yes. So how we can make the conceptual design for my ontology?
If I interrupt in between, Sonika, do you want to ask about how to draw it on the paper, means how to create a conceptual design, or do you want to ask how to make a computer version of it?
Ma'am, actually, I have seen some of the conceptual designs that you have already sent it to me, but still I am not, because that your ontology, legal ontology, I have seen. But in that case, you have started with the base ontology in which you have taken a class case. And that one of the middle class, that is a case, and through which you have connected that main class to different classes.
Yes.
How those classes are connected, and how we can take the properties like object properties or data properties, how we can connect all those things?
connect means you want to look the diagrammatically you want to ask in diagrams.net, how do we create lines and all?
No, ma'am. I want actually the concept. How we can do the things. कि किन चीजों के how we can connect the classes.
Ma'am, can I say here something?
Please go ahead.
So, ma'am, Sonika, ma'am, basically
Yes,
the thing
yes,
is, if you are talking regarding the case, the legal ontology, right? So
yes.
the thing is, there we are having the case as an entity, okay? Case as an entity, and that particular case are having the different kind of entities. Like, for example, if you just see, the case is having, for example, the court officials that are present there, okay? The case
Yes.
is having the different parties that are present there. Okay, so that is why it is actually, it is not a central entity that it is, that means even though the diagrams looks like that the case is the central entity and each and everyone is getting connected to it, okay? But the thing is, if you want to basically see that particular part, I'll just show you here. So for example, if this is the case, okay?
Yes, yes.
If this is the case, okay? So this particular case will have the case name. Okay.
Okay. Yes.
So
yes.
for example, it will have the case name in this way. Okay.
Yes.
So this case is having a case name, and this particular relationship is getting mapped with this. So here it will be the object property because both are, for example, okay, I'm just telling it as example. For
Yes.
example, if these are the two classes, so here it will be having the object property. The case has case name. Okay. I'll just write it here as has case name. Okay, so this is the object property. So now it is telling us, now whatever the case that we have, now that case will have the different type of entities and the relationship and the attributes. Okay, so here, for example, if you want to check, if you just see the party thing, the party class. Okay, so the class, the case name is having the party. Okay, so this particular class will get attached to another class here. Okay, so it will tell us as party. So in party also, you don't have to connect with the party class. Okay, if you can see, it is having the subclasses. So we are not connecting to the super class. We are connecting any one of the subclass that is present there. Okay, so it is basically not, it will not connect the case name with the class party. It will connect it to its subclass. For example, it is the petitioner. In this way. Okay, now this petitioner, now again this case name and this particular petitioner both are again the classes, so there will be the object property here in this way. Okay, the case name has petitioner, okay, or has party as a petitioner. I think it will be better if I just take it as a party.
Okay, fine. Yes.
Okay, so the party, one of the party of this particular case is a petitioner. Now, what is the name of that petitioner? Okay, so now name is nothing but it is a string, it is a value, right? So here we will have the particular data property. Okay, so this particular petitioner will get connected to this, and the data property will be in the form of string. So I'll just write it as a string. So this string, and now this particular relationship will be like the data property here. DP has name, has party name or has name in this way.
Okay. Yes.
I hope it makes sense.
Yeah.
Now.
Yeah. Yes, ma'am. Very clear. Thank you so much. Thank you, ma'am.
Thank you.
Sonika, you could connect later also if really something is left unexplained. You could connect later also.
Yes, ma'am. I will try on my ontology and I will take help from ma'am or you also. Yes.
Okay.
Yeah. Thank you, ma'am.
If other participants have something to say, something to discuss, actually it is a very, very important upcoming area, and all data on the web should be linked data. That was the motivation of this tutorial, to bring it forward. So if you people have something to say, please go ahead before we go through the third module of the tutorial.
Yeah, Sarika ma'am, can you please add those things in the module, that how we can make our ontology as 5-star? It is there in this third or fourth module?
No, not yet. Actually, it was a 3-hour tutorial, and
Okay.
module 2 was ontology. And with
Yes.
ontology, we covered this much.
Okay.
But Pooja already spoke about 5 stars.
Yeah, I have seen that. I have seen little bit about that. Yes, I can relate the things actually, but practically, I'm not able to do that. There was some problem
Okay.
in maybe.
Okay, hold on, Dr. Nandana. If you are there and you could throw a light on it.
Okay, can you please repeat the question?
The question is, say we have created an ontology, say Oligraph is there. We are uploading it on LOD as one of the bubbles. We are submitting it for LOD cloud. Then the number of stars we get. Sonika wants to ask that how could we get the maximum number of stars on our ontology when we submit it as a bubble on LOD?
Yes, yes.
Yes. So when you submit it to the linked open data cloud, there's a process of verification, like if the URIs are dereferenceable, if you have followed all the semantic web standards, if the ontology definition is syntactically and semantically correct. And then also if you have linked to other contextual data. So if, for example, if you have concepts, if you have provided all same as link to Wikidata, if you have provided same as links to other ontologies, if you have connected it. So each of these 5 stars in the 5-star rules, they have like different criteria for the star, right? So they will validate it. I think for the link open data cloud, if you don't comply with the 5 stars, they wouldn't even include it in the is part of the cloud. So in order to get it included and catalog in the catalog, you have to comply with the 5-star guidelines.
Okay. Okay, sir. Actually, I have tried to include all those things, all the rules for the 5-star. But in January, I have uploaded that ontology. At that time, for that ontology, it gets 3 stars.
Okay. So did you get some clarification, like which of the things that they didn't think you were complying to?
No, I didn't get anything from there, but I can check it out every time from last 2 months, because I have linked to some of the entities that I have taken from other ontology. I have linked those entities to the other ontology also. And RDF also it is there, but still it is 3-star. And
Okay, I think we can actually double check also. If you can drop an email to copying Dr. Jain and myself,
okay.
We can even take a quick look and see that if that's what is the status, right? So I think some of the things might be too strict, but I think we should be able to at least give some feedback on that.
Okay, I will do that, sir. I will do that. I will share it with ma'am.
Can we open your ontology right now here? Pooja can do that.
Ma'am, right now laptop is not there. I have joined through phone.
Pooja can do that, na?
Okay.
Please tell her.
Pooja ma'am, are you there?
Yes.
Go to lodcloud.net.
Yeah, LOD cloud. Can you please open the LOD cloud?
Yes.
Yeah, here the ontology name is super ontology. If you will browse.
Open the cloud. Yes. Browse it.
Browse. Yes.
It is connected.
Yes. And after you are done with this, please open your slide of 5-star.
Yes.
Because the 4th star Sonika is not getting, the reason is then others will start using the IRIs of your ontology. Then it will get the 4th star.
Okay.
Okay, so the maximum you could get was 3 stars.
Okay, yes.
So let us see when she'll display the slide of the 5 stars.
And the site is taking too long.
You are connected to Zoom, so internet is working.
Yes, yes. I think the name of the ontology is super ontology, right?
Yeah, yes,
In this
super
way,
ontology.
But it will not come on Google search.
Yes, no.
okay.
Pooja ma'am, you need to open LOD cloud. From there, we can browse it, and then only we can open that.
Actually, it's
Yeah,
not working now.
it's not working actually.
Okay,
Okay.
we could hold on and do it at some other point of time.
Okay.
You could
Yes.
send us a link, Sonika.
Yes, ma'am. I will share it. Yeah.
Huh.
Okay, ma'am.
Pooja, could you show the slide of 5 stars for a minute?
Yes.
It has come. Try browsing for once.
Ma'am, what did you say?
Try browse for once
Yes.
because it has already come now. Okay, leave that.
It is taking time.
Huh, I could understand.
So shall I switch to the slide?
Yes, you can.
So this is one.
Yes, could you read out the 4th star?
Yeah, it says use URIs, use open standard from W3C, RDF and Sparkle to identify things so that people can point at your stuff.
Okay, that
Means plus
she has already done, so she should get 4 stars. And the 5th star is link your data to other people's data to provide context. Okay, let her share it and then we can have a look on it. Okay, so yes, if there are any other questions, most welcome. Else we could move to the 3rd module.
Thank you, ma'am.